Welcome back to the classroom. My name is Mr. Wong. Today we'll be starting a new module on Earth and space. Today's lesson is going to be about the historical interpretations of astronomy. So the lesson intention for today will be to outline the different interpretations each culture had relating to space. Obviously, with a limited amount of time, we're only going to talk about a couple of cultures. And then the success criteria is just your ability to describe how our changes of the understanding of the universe has changed over time. Okay, so a couple of cultures we will be discussing is Indigenous Australians, the Incan Empire, ancient Greek astronomy, and the Renaissance. We did have the Middle Eastern countries as well, but that's been taken out just for this lesson. We might do a separate video on this later on. Okay, so let's firstly start with the ideas of sunrise and sunset. We all know that the movement of the sun that we see throughout the day is directly related to how the planet spins around the sun and how the Earth is spinning on its own axis. Now, let's look at how other cultures or earlier cultures first interpreted the phenomena of sunrise and sunset. So the culture we're looking at is Indigenous Australians, and their idea of how sunrise and sunset works comes with their sort of sun lady person. Now, just to put it into perspective though, there's a lot of different types of Indigenous cultures within Australia or countries. So this is just one of the very many interpretations that they use. So Walu, the sun woman, lights up a fire each morning, and that's what we describe as morning dawn. So when the sun rises, it's because the sun lady lights up a torch and she begins her journey running across the plain holding her torch. You can just sort of imagine like in the Olympics where they hold the Olympic flame, sort of like that kind of interpretation. And she travels from the sky from east to west. At the end of her journey, she goes back underground and returns to her starting point. So you can interpret as she's carrying the torch at this starting point here, carries it along, and then at sunset, or should be going this way, sorry. So sunrise going this way to sunset, and then underground she goes, and she repeats the cycle the next day. They also had an interpretation of the different phases or the different shapes the moon makes relative to its position with the Earth. So let's kind of have a look. These are all the different phases, as you can see. We do know the full moon is when the moon reflects all the sunlight onto us. The new moon over here exists because the moon has been covered up by the Earth, and so the sun can't have its light reflected off the moon towards us. So let's see how we get from here to here. Okay, so one of the interpretations is about a husband and his multiple wives. The story goes that this person at the full moon stage, so this is our full moon stage, the person was fat and lazy. Because he was so lazy, his wives would actually chase him around with an axe, presumably, I guess, to make him start working a bit more. A waning moon, which if we go back here, you can see the waning moon or the waxing moon here, is a sort of idea that his body parts are being chopped off, which is a rather brutal story to explain how the moon kind of goes from a full moon to a new moon. And then when it reaches a new moon, you can see that he actually dies of his wounds. If you actually see the cycle of the moon after the new moon has formed, in about 3 days or so, sort of a waning moon appears. So you have your new moon and then it begins to wane, so it begins to appear again until it reaches the full moon, and then it begins to wax off again. So that's kind of the story of explanation of how one Indigenous culture would interpret the phases of the moon. Now we move to ancient Greek astronomy, and this was sort of the first known cultures that gives a specific position of where Earth could be in the entire universe. Two really important models that they had, or observations, is this one here on the left. This is called the geocentric model. So the idea that Earth was in the center of the universe and all the elements, all the planets and stars were surrounding it. I'll get into a little bit more detail what it is. And then over here we have a thing called retrograde motion. If you look at the diagram that we have here, we had Mercury. You can actually see Mercury traveling, and then it sort of looks like it kind of loops around like so, and then it kind of deviates back along its orbit, something like that. So early scientists saw this kind of a motion. Depending on your perspective, sometimes this so-called retrograde motion looks like a little mini loop, so it kind of loops like that as well, depending on where you observe this thing. So these were two ideas, or one was an idea, one was a model, sorry, and one was an observation that they saw, and they tried to explain how everything worked together. So the first thing is we need to talk about where this concept of the geocentric model comes from. It was starting off with Aristotle, so the famous tutor of Alexander the Great back in 350 BC. He believed that all planets and stars were perfect spheres. So things like the Moon, Mercury, Venus, Mars, they were perfect spheres basically, and they all move in a perfect circular motion. So the idea is sort of, if it's a perfect sphere, it's, godly kind of interpretation there. He's also the person who created the idea of the four elements. So you have wind, earth, air, wind, water, fire. So there's that. He also believed that the stars that you saw did not move, so they were stationary and stagnant. So that was the early interpretation of what the universe would appear like. In the year of about 150 AD, a guy named Ptolemy developed this into what we now know as the geocentric model. So the idea is the Earth is at the center of the universe, and he used this model to explain the retrograde motion. So this is what we see here. Now, as we said just then, the retrograde motion is where you see a planet kind of do like a mini loop on itself, and do something like so. So the question was, why was this the case? And his idea, which he thought fitted well with the geocentric model, was if you imagine Earth being at the center of the universe, he predicted, based on the observations that he saw, was planets, let's say Mercury, would orbit around the Earth. But as it orbited around the Earth, it did what we call these retrograde motion eclipses like so. Okay, so that's how he saw the event. And to him, it made sense because the Earth didn't move. Now, the reason why the Earth didn't move, if you think about it, if you are in ancient society and all you see is the sun moving up and down, the moon rotating around, you would have the interpretation that everything revolves around you. So it's not so much so that they weren't intelligent enough to find a different explanation. They just simply didn't have other technologies to demonstrate a different perspective for them. The reason why I wanted to highlight the geocentric model, even though we now know the model is very much incorrect, is because it actually governed a lot of our interpretation of astronomy for quite a long period of time. This was later adopted by the church, I think around 1000 something AD, and it went on for another 600 or so years. So it wasn't until the early 1600s or mid 1600s do we begin to question the geocentric model and then move away from the model completely. A quick side trip before we go back on to answering what the new interpretation of the geocentric model is the Incan astronomy. So the Incans, if you would know, are in South America or Central America, and they had some quite interesting observations of their own. So they came up with the Incan calendar, and they also did some observations about the constellations and also the Milky Way. So they actually using their naked eye only, so they didn't have telescopes or whatever. They were using their bare-eyed observations, and they established one of the most accurate annual calendars on their observations of the sun and the moon and their relationship to the stars. They actually gave names to 12 lunar months, as you can see here. So for us, we had January all the way to December. They also had a 12-month system. These are all the suspected names, and these are the translations of the suspected names for it. So the next bit we have is, what did they know about stars and constellations? Well, their interpretation of what the Milky Way was, as you can see here, was that it was a river of water in the universe, and that it was the source of rain on Earth. So that was their interpretation of what the Milky Way was. They also used the sun-cross constellations as sort of a compass point. Okay, going back to Europe here, we have the Renaissance era. So that was about the 1500s onwards. The Renaissance era is quite consequential because of quite a lot of the big discoveries, and the changing of our understanding of the geocentric model occurred during this time period. During the Renaissance, a man called Nicholas Copernicus came up with a new model for the universe known as the heliocentric model. Now, helio actually stands for sun, and then you have centric. So heliocentric means sun-centered. So that's kind of what it means. So he came up with this idea that the Earth rotated on its own axes, and that all the planets that they observed at the time would rotate around the sun, with the sun being at the center. The sun would be motionless, and all the planets would rotate around it. If you actually look at this model here, you can see we go all the way from Jupiter to Saturn, and then we're missing Neptune and the other planets after that. The reason being is because they didn't actually know of the other planets' existence, because at the time telescopes weren't invented, so what they could actually see was just based on their observations. So there you have that. It wasn't until about half a century later, when a guy called Galileo Galilei took over from Copernicus' work. And his work is probably even more consequential because of the actual findings he managed to obtain. The most important part to his quest of understanding the structure of the universe and our current day knowledge now is with this device here. And as you can see, that's the telescope. Now, the reason why the telescope was so important, at least for our understanding of the universe and in support of what the heliocentric model being true, is the kind of findings he found using this telescope. The first finding he saw was the little craters on the moon. Now, if you remember what I said at the start of this lesson, was that Aristotle said all planets outside of Earth are perfect spheres, they're pure. So the fact is, this is going against the original model. You can see the craters on the moon. It can't be the perfect sphere that they so claim to be. Another thing was he actually observed the 4 moons of Jupiter. Now, if you also remember what he said about the geocentric model, is that if everything was to rotate around Earth, nothing else could rotate around anything else. The fact that there were moons orbiting Jupiter would imply that the geocentric model isn't entirely correct. And so this was actually the telescope, or one of the telescopes he used back in the day, so it's quite fancy there. You could see it's relatively small based in comparison to the really big telescopes we have now. So that's quite in itself impressive. So like we said, Some of his findings was the full moons of Jupiter, the craters on the moon. Another thing was the different phases of Venus. Now we know that if the moon was to rotate, or the moon rotating around us caused the different phases, the new moon and the full moon, the fact that Venus also did the same thing would imply that, it must be orbiting around something else, not entirely because of our planet. So these three evidences were quite consequential in support of the heliocentric model. And then you might have heard he had a little beef with one of the big players of the church. His name was Cardinal Bellamy, and they actually exchanged quite a few letters between each other. In a letter that Cardinal Bellamy wrote to one of his constituents, he actually wrote, "If there were a true demonstration that the sun is at the center of the world, the earth in the third heaven," meaning by the third planet orbiting the sun, and that the sun does not circle the earth, but the earth circles the sun, then one would have to proceed with great care in explaining the scriptures that appeared contrary. So why was this such a big deal at the time? Well, the big deal is because the church, as we said, adopted this model of how the universe was structured. And this has been part of their scripture. So the concept of astronomy at that period of time was interlinked with the Bible at the time. So Galileo coming up with this idea that the original model was incorrect and that there was a more correct model was quite controversial, because this is the established knowledge and established scripture. So that's almost to say that the scripture was wrong. Now, obviously, the debate with religion and science is way big to a topic to discuss for a year 10 course, and we're not going to look into that. But just know that there was a little beef on between these two people at the time. And so the main idea that happened after this was the cardinal said to Galileo, he believed that his evidence wasn't sufficient enough to prove the heliocentric model. And until he provided that model, the heliocentric concept that he is proposing cannot be seen as correct. Now, the actual evidence that he was looking for was this bit here, the epicircles. If you will remember when we first talked about the retrograde motion, so the idea that when on Earth, when we look at planets moving around us, they do this sort of loop movement. Their question was, how does this work if it was a heliocentric model? Okay, and that's basically that. Okay, so after this, the cardinal basically said to Galileo, if you dare to go out and talk about the heliocentric model as a fact without further proof, then you would be branded as a heretic. And, lo and behold, he did exactly not follow what the cardinal said, and he was put under house arrest. And, that was basically the story of Galileo at the time. But, as a matter of fact, his legacy is quite important because Galileo helped demonstrate the new evidence to show why the geocentric model was no longer the appropriate explanation of how the universe worked. And we actually know the heliocentric model was more correct. So let me just show you a little animation of what the difference between the heliocentric model and the geocentric model was. Okay, if you actually have a look, the heliocentric model has the sun at the center and all the planets rotating around it. The geocentric model, you can see the Earth at the center, and then you can see kind of this spiraling mess that's occurring here. Now to put it simply, the heliocentric model is still incorrect because the sun isn't at the center of the universe. We now know that there are galaxies and the other galaxies besides our own galaxy. To explain how the retrograde motion actually works, there's some really nice videos on YouTube that you can look into as well. But in simple terms, it's just based on the relative motions between each planet that gives you that illusion the planets are looping around you. So that's kind of the deal there. That concludes our lesson for today about the different historical interpretations of the universe. There are many other scientists who contribute to this idea, but this is all we can cover for today's lesson. Until next time, take care.